Welcome to Sri Lanka DevOps community. In today's session, we are going to discuss about Azure Kubernetes Services Ingress with Azure Application Gateway Ingress Controller. Application Gateway Ingress Controller is a pod deployed into Azure Kubernetes Services, which will monitor the Kubernetes APIs to understand the Ingress needs and then apply the configurations to Azure Application Gateway. In the Application Gateway, necessary listeners, backend settings, pools, rules, and health probes will be created based on the Ingress definitions that is created in the Kubernetes site. And then Azure Application Gateway would be able to access the pods and provide access to the outside services via the public IP or the private IP of the Application Gateway. There are two modes you can use to deploy Application Gateway Ingress Controller into AKS. One is as AKS add-on, which will support greenfield and brownfield deployments. Greenfield means you can use a new Application Gateway to deploy it as an add-on for Ingress purposes into the AKS cluster. Or you can use an existing Application Gateway and still deploy it as add-on mode into AKS. So when you do that, that particular application gateway will be fully taken over by the AKS, and then whatever the settings that are manually created in the application gateway will be fully removed, and only the Ingress requirements of the AKS cluster will be applied to the application gateway. But if you want to keep a shared mode, the possibility is there with the Helm-based deployment. Even with the Helm-based deployment, still you can allow the Application Gateway Ingress Controller to fully take over the Application Gateway, or you can opt to have it in the shared mode. If you are having it in the shared mode, the Application Gateway can be used for the purposes of the other Azure App Services, such as App Services or other AKS clusters. When you are using the add-on mode of the Application Gateway Ingress Controller, it will be fully managed and the updates will be applied automatically. However, in the Helm mode, you have to update the Application Gateway new versions manually. Let's look at a demo to understand how the Application Gateway Ingress Controller can be deployed with add-on mode, to get a broader view of like what it is and how it works. Maybe on a later video we can discuss about the other ways of deployment and the advanced topics. But today, in a simple terms, let's try to understand what it is. To begin with the demo, let's explore the AKS cluster that is existing. So I have created an AKS cluster with networking as Azure CNI mode. So you can use container networking interface as Azure, or you can use Kubernetes. Either way of usage of the networking, you can still use AKS as AKS with Application Gateway Ingress Controller. So there's no limit. You can use either Azure CNI or Kubernetes as your networking interface. Still, you can use Application Gateway Ingress Controller. And I have deployed this cluster with two node pools, which is Windows and Linux. So that's why I needed Azure CNI. Then I have deployed a namespace called demo here. And I have deployed a workload, which is a deployment of an API. And inside this deployment of the API, I have a pod running, which is having a container, which is having a simple .NET application or API returning weather forecast details. So it's not about invoice, but just producing weather forecast information as the basic template. And this particular workload can be accessed via cluster IP using port 8091. And if you look at ingresses, we have not defined any ingresses, or we don't have any ingress controllers defined here. So there's no ingress as of now. So how can we first access this and see if the service works is using port forwarding of Kubernetes. So Kubernetes kubectl port forwarding we can use to access this cluster IP and check the API is working or not. Let's switch to Visual Studio Code and then try to see what we can see as port forwarding. But before that, I'll just explain how I have deployed this. You can see the deployment YAML file here, which is deploying the container, and I have asked to deploy it to the Linux nodes, and then I have created a cluster IP, which is actually using port 89 to access the container. So it will be mapped to the port 80 of the container and then be accessed by cluster IP. Now, to see what are the services deployed, I can execute command kubectl get service in namespace demo. When I do that, I can see invoice API cluster IP service is there with port 8091. And to do a port forwarding to this one, I'll just try to get the command that is there. You can type kubectl port forward and then say service / invoice API cluster IP, and I'm going to map port 8085 into port 89 and use the namespace demo. And when I do this, my localhost port 8085 will be mapped to the port 8091 of the cluster IP of the Kubernetes cluster. So I can try to access the application now using port 8085. So let's try to do that. So I'll just say localhost port 8085 invoice API swagger, and you can see the invoice API is loading. To check if it is actually accessing the Kubernetes cluster, what we can do is I'll try to log into the WSL here, and then okay, that is password incorrect. Let me see. So that's good. Then I'll say kubectl get pod in namespace demo, where I can see invoice API is running as a pod. And if I try to access logs of this pod, kubectl logs, and I need to copy the pod name here and paste the pod name and say namespace demo, and you can see it has been accessed. So instead of getting all these logs, so you can see the Swagger is accessed, but it doesn't matter. Let's try to execute the API and see if it is actually accessing from the pod. So I got the details from the API, and if I check the logs, you can see it's calling the weather forecast controller and then returning the details. So we are actually accessing the pod, and so that's great. So next step is actually, this is just basically doing a port forward and doing access, but we need to do application gateway Ingress controller based access. So how can we do that? Let's try to stop this and try to create application gateway Ingress controller in our AKS cluster. So in my AKS cluster, I can see, okay, I'll go and show another thing as well before I move on to creating this thing. That is, my AKS cluster is deployed with virtual network. So any AKS cluster will have virtual network. I have pre-created the virtual network, that's why it's there like this, because I created this in Azure CNI based. But if you are doing Kubernetes, then the virtual network will be created inside the MC resource group, which is getting created for the other resources. Now, if you explore the subnets here, you can see the default subnet, which is for the AKS, having larger range of IPs because each of these pods getting deployed requires IP from the virtual network subnet. So that is why that is created as a large range of IPs. We can discuss about these facts in a maybe later session or video. Let's move on and try to just have a look at the resource group of the AKS. So you can see there are two node pools and then a load balancer. So all these things are here. So let's try to deploy our Ingress using Azure Application Gateway Ingress Controller. To deploy Application Gateway Ingress Controller, what we have to do is go to the Networking tab and just select Application Gateway Ingress Controller here and select it. And what you can do is you can say create new, but the name would not be able, you would not be able to change the name if you are using this add-on mode. If you are using Helm chart, you can actually maybe able to change it, or you can create an existing application gateway and make it change with the add-on mode as well by selecting the existing application gateway here. Now I don't have any application gateways deployed, so I'm going to deploy it right now with the default name, but I would be able to change the IP address if I want, IP address range, but I'll leave it as it is and then apply this change. So you can see it's getting applied. It will take a couple of minutes to get applied. Let's wait a bit and see. It shouldn't take that much longer, but anyway, let's refresh and see how fast it gets applied. Okay, it takes 15 minutes. No, I don't think so. It'll only take 1 or 2 minutes. Let's wait. Let's see if it is done. Yeah, it seems it's done. So let's go and explore if the Ingress is correctly created. If you go to the subnet, you can see a new subnet is created for Ingress app gateway. Then if we go to the MC resource group of the cluster, you should be able to see the Ingress app gateway is created, and then a public IP for the app gateway is also created with a managed identity as well. And if we go into the Ingress app gateway, we would be able to see a default listener is created and a default rule is created. A default health probe rules is not there, but there's no backend properly set up, but like there will be default settings etc created, and you can see it's still saying it's updating. So it's somewhat pending yet, but until it is getting ready, we can go and discuss how we can deploy Ingress into AKS, which will create the Ingress in the AKS and then make it as backend settings and backend pools and listeners in Ingress app gateway. So there'll be rules etc set up. So let's go and explore the how we can define an Ingress. So the basic requirement to define an Ingress is here in my commented code. So let me try to uncomment that particular code. Okay, I'll try to highlight and uncomment. Okay, so you can see I have defined Ingress. Even if you are using Nginx, the class should be Nginx, but we are not using Nginx. So for the Ingress class, we have to define Azure/application gateway, and then I need to define a health probe, because health probe is mandatory to verify the backend health of the API that is deployed into the IKS cluster. So app gateway will create a backend probe. Since I don't have a proper API health endpoint defined, I'm just using the Swagger, so that should be okay because it will be returning a valid return, which is around 200 something, 204 something. So that should be okay. So if I remember correctly, we can check. It's 200 or 204 that is getting returned. Yeah, 200 for the Swagger. So that should be totally okay. And then we are mapping a path similar to Nginx, and we are just mapping to the port and the cluster IP. And you can define host names, etc. here, or you can say to use the private IPs, etc. All these things we can explore in a later session, because it's a bit advanced topics. Defining SSL would be another topic that we can explore in our next video. However, let's just have a look how we can get this Ingress deployed. So I'm using a make file here, which is actually applying the Kubernetes using kubectl apply. So I'll just say make, which will create the Ingress for me. So let me try to say make. So you can see there's no change to the API or the cluster IP, but there's new Ingress setting created in the AKS cluster. In our AKS cluster, if we go to services and ingresses now, there should be an ingress defined. So you can see invoice API ingress is defined here. Let's go and explore the app gateway as well, so we can easily go to that using this one. So when we go to the Ingress app gateway, let's look at the backend pools. So you can see a backend pool is defined for the invoice API cluster IP. There'll be backend pool defined, and in that backend pool we can see what are the backends defined. So you can see an IP address here. So what is this IP address? So if I try to open the AKS networking, maybe in another tab, let's let it okay, it opened up faster. So if I explore the workloads and go to the so you can see a pod running. This is the application gateway Ingress controller pod. So if we go to the pod and check the IP of the pod, if I go to the pod, so you should be able to see the IP. Yeah, IP of the pod here. So you can see this particular IP is used in the backend of the backend pool. And if we add more pods by increasing the replicas, there'll be more. So let's try to do that as well, just to understand if it works really. So I'll change this replicas to 2 just to make sure that it's getting deployed more than one instance. So I'll just say make here, and you can see there's a configuration happening here. And if we inspect the number of pods here, you can see there's new 2 pods getting created here, and you can see the backend pool. If I go outside and come back again to this backend pool, there should be 2 targets now. So let's see it's getting applied or not. Yeah, you can see 2 targets with the 2 IPs of the pods. So this will be load balanced automatically by the application gateway. And further the okay, I need to go back to the Ingress app gateway just to show you the listeners and backend settings. You can see backend settings is getting created as 8 port with port 80 for the invoice, and then you can see a listener getting automatically configured, and you can see okay, how you define with private IP, etc. Let's talk in another session or a video. And in rules, you can see a path-based rule is created. So as the listener is used, and then you can see the path-based rule invoice API asterisk will be directed to the target backend settings and the backend pool that is for the invoice API. And if you go to health probes, you would be able to see it has set up invoice API swagger as we have defined in our Ingress definition as the health probe here. And you can see the health probe path here. The health probe should access this particular URL. So the Ingress settings health probe also defined here in the application gateway. And if we check the backend health, we should see it as healthy. Let's wait and see. Takes few seconds to load that. While that is loading, we can go and check if the actual service is working. So what we can do is go to the ingresses here and then go to the IP address. Okay, we get a back gateway because we don't have the IP address exposed. But if we say invoice slash API slash forecast, maybe. Okay, you can get the forecast. And if I say Swagger here, I will get the Swagger. So you can execute and see it's serving from the Ingress. So Kubernetes Ingress is defined and it's serving via the public IP address of the application gateway. So if you can see the backend settings are healthy, and for the 2 pods there's 2 backend settings defined, and in the backend pool there's 2 pods, so that's why there's verification for health in the 2 pods. So Ingress will be managed by application gateway, and the load balancing also will be managed by the application gateway as well. So okay, what happens if we deploy more than one service here? So I have actually defined pipelines etc for this one. So I have multiple APIs which can be deployed to this cluster. So I'll explain these APIs in the next video, but API deployments with pipelines in the next video. But just to show you what happens if we have more than one service, I'll deploy a couple of other services here. So I will just do only the deployment part of it to make sure it's done fast. So I'll deploy 3 other APIs here. One is payment, and then I'll deploy one order API. We try to deploy that as well. I'll rerun this stage, and which will make the deployment happen to the AKS cluster. And I'll deploy the custom API as well. So you can see more than one API can be used. Okay. So let's see if these pipelines are done. Should be done in very quick time. So we can just refresh and see. You can see payment API is already done. So if we go to our AKS cluster, we should see a workload for the payment now. Now it's using the similar, you can see the pod is running now. But I'll show you the, just for the sake of explaining, I'll show you the CI/CD AKS template. So this is actually the same template, almost same, and it's actually having tokens which are defined to replace even the names using the pipeline. So if you are familiar with the pipelines, you will understand what it is, but we can discuss these things in a later session or video. So just have a look at the IP address of this one. So you should see something, one pod is running, and if we go to the Ingress app gateway, now there should be, if I refresh the backend health, there should be 3 backends. Okay, until it refreshes, we'll just go and see if it actually works. If you go to Ingress and look at the ingresses, you should see, okay, all the things are deployed, but let's check the payment API first. So instead of using the invoice API here, I'll try to go to payment API. Payment API. Okay, payment API also works. So I'll just execute this. It's again with the forecast API, nothing bad about that. However, you can see there's 4 services ingresses are defined here with as workload wise. You can see 4 pods are already running, and all these 4 services can be accessed with the Ingress here, and all the 4 services, yeah, backend health is working fine as well. So you can see different backend healths are defined, and since we have 2 instances of invoice API, you can see 2 backend health is verification happening using the health probe for each of the pods. So this will essentially make sure the all the pods are verified and etc. and Ingress is happening to both the pods. So it's great. Load balancing, etc., will be managed by the Ingress. So it's nicely working. And you can check the backend settings. So there's 4 backend settings automatically generated. So we didn't do anything manually here. Like, we just defined the Ingress from the cluster side, and automatically it gets applied. So what happens if we delete one of the ingresses? So I'll show you that as well. Just to give you an idea, I'll just delete it from here. So I'll delete the customer API Ingress, and I'll confirm delete. Okay, done. And then we are coming back to here and refresh the backend pools. So immediately disappears. So there's no customer backend setting or in rules. Okay, let's check the rules, what it is. And if you go to the rules, you can see now only 3 rules are existing. So if I deploy the customer API again, it will be creating customer route path as well here. So this is basically what it is all about, the application gateway Ingress controller, and it's fully managed by the AKS cluster, because we are using add-on mode. And if you want to have more shared mode application gateway, then you have to use Helm and then say it is a shared application gateway. But we can look at those stuff in maybe in a next session or a video. So this concludes this particular session, and I hope you now have a basic understanding of what is application gateway Ingress controller and what it can do and how it can manage application gateway and enable Ingress to your AKS cluster using the application gateway. So this is really nice, because this is providing load balancing and security as well. So you can use private IP to implement the security as well. But those advanced topics or SSL based routing we can discuss in a next video. So thank you for your time for listening to me in this session, and I'll hope to see you in another video soon. So thank you. Bye bye.